And good evening, everyone, and welcome to the other side of midnight. That kind of, magical time between dusk and dawn where the things that we kind of ignore in daytime, we pass by and say, it's too much trouble, or I don't believe that, or whatever. At this time of night, we kind of get into it. I mean, really get into it. And this morning, we're getting into something extraordinary. Now, you know that the title of tonight's show, which I very carefully thought about, and I thought to myself, is this going to be overhype? Is this going to be, over the top? Is this too much of a good thing? No, it's not. Because tonight we're going to talk about, in my opinion, and I'm hoping of my guest, at least his whole book seems to document this position, the greatest scientific cover-up in history. And by the end of the next 3 hours, you're going to understand why I say that. So I'm not going to give the game away. We're going to let Jim, portray this extraordinary story in full color in 3 dimensions for you, and we will go from there. In the meantime, if you go to theothersideofmidnight.com, that's our home page, click on tonight's banner, the greatest scientific cover-up in history for October 19th. I think we're going to have to change that old that title. We have a previous date when Jim was supposed to be with us, and for reasons that we may or may not talk about tonight, he was unable, because of conditions beyond his control, to join us. So we might in future years or future months want to change that date. But tonight is the 19th of October, Saturday night on the radio, and we have an extraordinarily intriguing adventure ahead of us. In the meantime, scroll down on the guest page. If you click on the banner on the home page, it takes you to the guest page. Go down below Radio with Pictures, or you can click on the fast links right under the DeMeo banner where it says fast links to items, Richard and James. Click on me, and that will take you down. Actually, it doesn't. It's not working tonight. Weird. Oh, there it is. Okay. That will take you down to some items that I'm going to talk about. First of all, of course, I'm running this week after week because it has not gone away. This problem, this incredible problem with, the Bahamian disaster, the Armageddon going on in the Bahamas, it's still ongoing. Those people sat under Dorian, a Cat 5 hurricane, for 2.5 days, and nothing was left, just kindling and splinters and debris and lots of very dirty, very awful, horrible water. They're surrounded by an ocean, and they couldn't drink a drop. So you want to click on both of those links, because the first one, of course, is some of the imagery which has been updated from the heartbreaking aftermath of Hurricane Dorian. The second link is all of the medical aid and assistance that you could click on and send money. Project Hope, Team Rubicon, the Bahama Red Cross, Hurricane Relief, the Salvation Army. All those links are there. Take a look at those pictures. Imagine yourself in that situation. God help us that you never have to be in that situation. And reach to the bottom of your heart and give what you can, because these people, even though you haven't seen any news stories for weeks and weeks, it's the moving finger moves on. So news is following many of the things going on around the world, including Syria. But the Bahamas should not be forgotten, and what those people are going through, and there's still, most of them, 60,000 people still affected. Very few were able to get out to safer places. So the international relief agencies are trying to help those people that literally cannot leave because they don't have the wherewithal to leave. So if you want to, if you need to, if you feel that you want to, if your heart is moved, by all means, click on those links under number 2 and give whatever you can, because it will be incredibly appreciated. Okay, without further ado, let me introduce my guest of the morning, because we have an awful lot to talk about. James DeMeo, Dr. James DeMeo, formerly studied the Earth, Atmospheric, and Environmental Sciences at Florida International University and the University of Kansas, where he earned his PhD in 1986. At KU, he openly undertook the first graduate-level natural scientific research specifically focused upon Wilhelm Reich's controversial discoveries, subjecting those ideas to rigorous testing with positive verification of the original findings. DeMeo subsequently undertook drought-related field research in the arid American Southwest, in Egypt, Israel, in sub-Saharan Eritrea, and Namibia. His work on Sahara Asia questions resulted in, it was the most ambitious global cross-cultural research study to date on the subjects of human behavior, family and sexual life around the world, and particularly in arid desert areas. Dr. DeMeo's published works include dozens of articles and compendiums, and several books including Sahara Asia, the Oregon Accumulator Handbook, and In Defense of Wilhelm Reich. He was editor of On Wilhelm Reich and Origami and Heretic's Notebook and of the journal Pulse of the Planet, as well as being co-editor for the German language compendium Nach Reich, Neue Forschung zur Origami. DeMeo has served on the Faculty of Geography at the University of Kansas, Illinois State University, University of Miami, and the University of Northern Iowa. His past or current affiliations, take your pick, include membership in the American Meteorological Association, the Society for Scientific Exploration, Arid Land Society, the Natural Philosophy Alliance, Sigma 11, International Society for the Comparative Study of Civilizations, and the AAAS. That's the American Association for the Advancement of Science. His latest credit, of course, is this book we're going to talk about tonight, which I think in all fairness may be his magnum opus. It's called Correcting a Major Error in Modern Science, The Dynamic Ether of Cosmic Space. Without further ado, welcome back to the other side, Jim.
Well, thank you, Richard. Thank you for inviting me again.
Well, this is one hell of an intriguing topic, and it's almost impossible to know where to dive in. So maybe we should do this kind of chronologically. When did you, with that really eclectic background, when did you get intrigued with the idea that space is not an empty vacuum?
Well, subjectively, when I was a kid, I was the kid on the block who had a microscope and a telescope and wasn't too interested in sports, although I loved baseball. And when I later in science classes in school, they started talking about empty space, it just was a puzzlement to me. Years later in the university, when I was in an undergraduate in the university, I read about the cosmic ether, of course, in detail, as most every science-oriented university student will. And they were saying that this disproved the ether, and the ether was understood and described, of course. And so they said it was disproved by the Michelson-Morley experiment. And then there was this curiosity of statements about another scientist by the name of Dayton Miller, who they said, well, he got positive result, but, it was just temperature effects. So this piqued my interest, and I actually went back and I read the original research papers of Michelson-Morley.
Now, how old were you then?
That was when I was a teenager. Probably around 18, 19, something like that. And, in disbelief, what I read, Michelson-Morley said they got a positive result right in their 1887 paper that everybody's always quoting, but apparently very few people have bothered to read. And
so wait. If you were 18, 19, you had to find that paper by going to a library. Remember those folks? Big place, lots of books, magazines, newspapers. So you couldn't just look it up.
I had access to the University of Miami library and the Miami Public Library, which was pretty good. And some of the books I was reading gave copies of this paper by Michelson-Morley, In particular, there was one called The Ethereal Ether by a historian, Swenson, I believe was his name. And he reproduced this paper in the back of his journal. And it's ironic that in the pages of it, not his journal, his book, in the pages of the book, he's describing how the ether was not proven by them. But then you go back and you read what Michelson Morley wrote, and it's very clear that they said that there was something detected. And while I'm talking to you, I'm looking for the exact quote here, because I think it deserves just to...
In the Michelson-Morley paper. Now, that was Albert Michelson, and what was Morley's first name?
Robert Morley.
Okay. Albert Michelson, Robert Morley, okay. Now, you're 19, you're reading this, and this is your first encounter with something we're going to talk about a lot tonight, which is the cognitive dissonance of academic science, where whatever is actually published is completely misrepresented by those people publishing it without a trace of irony or a trace of embarrassment or whatever. Because this guy who wrote this book, he said, oh, there's no such thing as ether. And in the back of the book, he reproduces the paper by Michelson and Morley that said, there is such a thing as ether. How at 19 did you reconcile those two irreconcilable positions?
Well, first of all, let me correct something I said. It's Edward Morley, not Robert. It's Albert Michelson and Edward Morley. Well, look, I read this stuff and scratched my head. At that time, I was out of high school and joining in a rock and roll band, so it was not exactly like I put this at the forefront of my of what to do. I was a rebellious teenager, and I read this stuff with great interest, but it sort of got put in the back of my mind until a couple of years later, when I decided to go back to college. And so in the university, starting out at Florida International University for my bachelor's degree, and that's where I began to put more detail to this. And part of what you say is true, that there's certain kinds of denial mechanisms that kick into the mind of science, which at the time of science, when I was a kid, when you were a kid, the idea of empty space and a dead universe was fact. I mean, that nobody taught it differently. Everybody said that ether did not exist. There's no energy in space, and nobody had any reason to question it.
Well, wait. Let me ask you another question then, because when I was growing up, and I guess we're roughly the same age, the thing that struck me about the relativity thing, Einstein and all that, is Einstein talked an awful lot about the properties of space, its capability of being warped, its capability of showing shifting stars near the sun because of gravity, its capability of changing orbits because of this warpage. And I always thought naively, well, if something can warp, there's got to be a kind of a there. There's got to be something, a substance that's being warped, even if you call it by a different name. So I always thought that the ether had merely morphed in terms of language to warpable space, but there still was a there.
Yeah, well, Einstein later, the progress of his theory is rather convoluted. He, at one point, made a lecture where he said that the ether could exist or does exist, but it has to be something with no properties whatsoever and cannot affect light. And yet these experiments that we're talking about, the ether drift experiments, these were designed to detect very slight changes in velocity of light depending upon the direction in which it moved, and in order to detect the direction of the Earth's net motion in space. So you were trying to figure out in which direction the Earth was moving and how fast by measuring the variations in the speed of light as it moved in one direction versus another. And the original expectations that were handed down over the years to Michelson Morley when they did their experiment in 1887 was a concept of a static ether. In other words, that the ether was like some kind of a smooth thing that existed out in space with no wrinkles or variations in it.
Like a very uniform jello, extraordinarily thin.
Something like that. It was but it had no real properties other than it was a medium for the transmission of light waves. And for those who are struggling with the issue of ether, maybe I could just mention this, that the ether was proposed to explain the wave properties of light. And in the same way that when we speak about sound waves, it requires a medium, and that medium is the air. Sound waves do not transmit through a vacuum. And water waves also wave in the water. You can't have water waves without the water, obviously. So if light exhibits the properties of wave motion, it can be reflected, refracted, interfered, and so on. What's the medium through which the light from the stars and the sun is coming down to us from Earth, or just for transmission at the surface of the Earth? Light will transmit right through a vacuum, unlike sound. And
so, who was the first scientist to propose this static medium which transmitted light as waves?
Oh, well, I think maybe you'd have to go back to the period even before Newton. I mean, Galileo was speaking about the ether, Kepler, Newton, of course. And Newton, before Newton, the idea of ether was as a ubiquitous force in nature, a prime mover that was responsible in part for the motions of the universe.
Hang on. But how do you define a prime mover?
Well, one of the questions of the philosophers, going back to the ancient Greeks, is where does all the motion of the Earth come from? You have the planets and the stars move, and the heavens move over us on a 24-hour basis, and the motions are regular and systematic, and there was philosophical questions raised about the origins of motion in the universe. So ether was something that was originally considered to be something, well, if you go back to the Greeks, it was the name of the heavenly air that the gods breathed, as opposed to the normal air down here on Earth for us mortals. So you find it, the old archaic ether, spelled with an A, A-E-T-H-E-R, had certain religious and philosophical connotations. With Galileo, you begin to see more feet on the ground kind of attempts to understand this. He was actually one of the first ones to try and measure the speed of light. He did so by having somebody stand on a hill at a distance at night, and Galileo would open his lantern to that other person, and then the other person would then open their lantern, and then Galileo would shut his, and the other one would shut his, so that he could get a rough guesstimate of the speed of light. And by this, he argued that the speed of light was probably something like around 6 times faster or 10 times faster than the speed of sound. And he had done experiments with the speed of sound by having somebody fire off a pistol on another hill after he had fired his own pistol. So he could gauge the time going out and coming back and divide that by 2, and knowing the distance, he could figure the velocity of sound. And it was very, very approximate, of course. But when you start coming to Newton, he's really the genius expert on optics and so many other things. But he embraced the ether concept when he was younger.
I'll tell you what, we're at the bottom of the hour. My guest this morning is Dr. James DeMeo. We're talking about his magnum opus, where he covers from A to Z the history of the explorations of an invisible medium in space that you're going to find out by the end of the morning does an awful lot of stuff that's done by a lot of other theories, and does it very elegantly, very simply, and most critically has been measured as opposed to everything you've read in every modern textbook on the subject. You're on the other side of midnight. My name is Richard C. Hoagland. We shall return.
theothersideofmidnight.com. Tune in to listen to Richard C. Hoagland and his fascinating guests. Join Club 19.5 to get access to exclusive member benefits. Listen to past episodes anytime on any device. Search the archives of over 180 episodes. Membership costs $9.95 a month, 33 cents a day. Support the broadcast that provides you with the most interesting conversation available. Talk radio at the cutting edge of science and thought. theothersideofmidnight.com.
And welcome back, everyone, to this Saturday night, October 19th, The Other Side of Midnight. We're talking about cosmic stuff tonight. Is there a medium permeating all time and space, the pores of even supposedly solid matter, that somehow is involved with or maybe even governs their motions around other objects, their rotations, their spins, their interactions as what used to be called ponderable bodies? We're getting into all of this tonight because it has, if this ether is real, if the last century or so of textbooks is really, 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 really wrong, it means that modern science is wrong, that the foundations of what we think we know have been limited. And one of the questions that we're going to get into tonight is, has it been limited by ignorance or has it been limited by design? Jim, you're back.
Hello. One point I feel I should make, nothing I'm going to say here tonight invalidates the factual record of experimental science. What is challenged are the major theories of astrophysics which attempt to explain the data. So the observations of the astronomers are real, and there's no question about that. But the question is, how are they explaining things? And they're explaining things on the basis of of empty space and a dead universe. And that is what is at issue. Because when you start looking at the history of the ether experiments, you find that they aren't showing negative results. Some of them are, but a lot of them are not. And as to the reasons why the Michelson-Morley experiment had been rejected at the time when it was first brought out, I was elucidating that Newton, years earlier, about 100 years earlier or more, he had elucidated the ether firstly as something quite tangible that could be seen in optical phenomenon. But as an older man, he began very preoccupied with religion and the hereafter. And what happened was he's reading the Bible, and he's getting the view that from the Bible, it's saying that God created the heavens and the earth, put it all into motion, breathed life into the cosmos. But that was all that Newton wanted to know. And when the ether was being considered as a ponderable medium which moved, which caused movement of the heavenly bodies, this he objected to. And he's in his queries in a major book called Optics, which is filled with wonderful, genius insights. On this issue of the cosmic ether, he just basically says flat out, it is unphilosophical to question what's in the holy books, a holy book, the Bible, on the question of how things move.
Richard C. Hope.
So the ether was made static and immobilized, even though he accepted it as the medium through which light waves moved. But then, even later still, he got away from light waves and started talking about light as a shower of particles. So you have the particle theory of light on the one side is it's coming up since Newton, and other people are arguing for light waves. And to the modern times where we get to sort of a mutual agreement that there's particle waves or wavicles, they call them, which I think is a mistake, but that's another question. The whole point being that the ether was considered as a real thing and discussed by all the top scientists of the period of the 1800s up until the 1887 experiment of Michelson-Morley, but they were almost all in agreement that the ether was something that was static, which the Earth moved through it, much like a bullet moves through the air. So they were expecting a very high velocity of ether motion. Now, Michelson-Morley found a slower velocity of ether motion than what everybody expected. And this led to misinterpretations that, the velocity was, some said it was too slow, and therefore the ether didn't exist. This was the big error, because there was theories.
Give us some numbers. What were they expecting? What did they actually find? Okay. And in the numbers, is it because the actual number was so low compared to their expectations, they basically doubted the
It was a reasonable
readout?
percentage. It was a reasonable percentage. Let me give you an example. The original experiment of Michelson-Morley was aiming to detect the 30 kilometer per second motion of the Earth rotating around the sun. Okay. That's the speed approximately of which the Earth is moving around the sun, 30 kilometers per second. And what they obtained, as I'll just quote here from their paper, they say the displacement to be expected was 0.4 of the fringe value, which is the reading that they're making, when the actual displacement was a 20th part of that. And they're saying the relative velocity of the Earth and the ether is probably less than 1/6 the Earth's orbital velocity, and certainly less than 1/4. Now, when you do a little bit of arithmetic on that, it's a velocity of 5 to 7.5 kilometers per second.
Mm-hmm.
Now, that's not nothing. It's something, and it's significant. 5 to 7.5 kilometers per second is a fantastic speed.
Well, wait. If we're dealing with something like 20% of their expectation, is that true?
Approximately, yes.
Okay. There are modern scientific experiments where huge papers and Nobel Prizes are awarded by percentages like 0.0001.
Exactly.
I mean, it's nuts. Yes. Why would they ignore an actual, real, reproducible, 5 kilometers, 7 kilometers per second is faster than anybody could ever propel anything in that era. It should have blown them away.
The issue of the ether being static was so ingrained in people's mind. If you start talking about emotional ether, then it has to be involved in gravitation. It has to be. There's reasons for that. And if you're talking about a gravitational ether that is moving the planets along, this is heresy. This is major heresy. And so it's a lot easier to throw out the result of Michelson-Morley, what they actually measured, and ignore it, than it is to suddenly find yourself. It's like you think you're standing on solid ground, and then suddenly you find you're free falling through space. Everything you thought was true isn't, at least on the basis of theory.
Oh, wait. Isn't that the objective of science? To find
of
stuff
course it is.
Why do scientists, even in that day, which was much less politicized than it is now, with federal money and huge grants and, publisher perish and all that nonsense, why didn't somebody of that era, more than somebodies, look at this and say, oh my God, we've just discovered something amazing?
Well, there actually were. There were scientists of that era, such as Stokes.
Of famous Stokes law.
Yeah. And I'm trying to remember. Lawrence actually originally thought about the ether as something that could condense around the planets to a thicker value and move with the rotation of the planets.
So wait. You made a jump. If we're not moving through a static ether where the full wind, the ether wind, is blowing in our face, and they would get the 30 kilometers per second if they were on the right side of the Earth facing its forward motion, and they're getting a much less velocity, what was the obvious logical interpretation if the reading was taken as not an instrument failure, but a real reading?
The logical argument was that the ether itself had material substance. It wasn't just for transmission of light. It had material substance sufficient that when the Earth moved through it, that a layer of ether condensed around the surface of the Earth and became thicker and therefore slowed down in its velocity.
So it was not like a cannonball moving through a smoke-filled room where the smoke doesn't affect the ball at all. The ether was actually somehow. The ether was somehow.
Metal ball. If you can imagine a large metal ball being dropped into a bucket of honey, and it suddenly slows down, and there's a layer of honey that's sticking to the ball as it is moving.
So the new idea would be, if the readings were real, and most people said they're not, but those that did said, okay, it means the ether somehow has to interact with the Earth, with matter.
That's right.
It isn't just this immobile thing that's out there surrounding everything and totally frictionless, totally non-interactive, totally non-conductive, totally doesn't even know the Earth exists. There had to be some relationship, some interaction between the two, and that explained the much lower reading that Michelson-Morley got compared to the expectation.
Yes. And it's very interesting that Michelson-Morley knew this. And they also wrote that it's just, I'm not going to quote exactly here, I'll sort of paraphrase. They say that it is just possible that if we moved our instrument up to the top of a high mountain, that we would get a higher velocity.
Wait. You mean he suspected that the readings might change if they could get high enough to where the entrainment, the interaction between the Earth and the ether was less?
That's correct.
Okay.
And they said that the experiment, to remove all doubt, we have to do this experiment on a high mountain at 4 different seasonal times of the year. So we know what the variations might be in the seasonal variation in ether drift. Now, they never did that.
What?
They never did that.
Why not?
Well, reasons of personal change. The whole subject was suddenly grasped by the physics establishment as proof that the ether did not exist. These were younger, at least Michelson was a younger guy. And I think, when I read through his biography and read through the experiments, they only did 6 hours of data collection over 4 days. That's another thing. 36 turns of their interferometer.
Wait a minute.
device.
You're talking about a paper that became the cornerstone of all science. There's no ether, and it's based on a lousy 6 hours of data 100 plus years ago?
That's right. July 8th, 9th, 11th, and 12th in 1887, a grand total of 36 turns of this interferometer device that Michelson built. And the interferometer is a wonderful instrument. It's still used today for all different kinds of things. But
well, I remember from when I was your age, growing up, that kind of thing, that Albert Michelson, for me, beyond the Michelson-Morley experiments, claimed to fame was because he designed and put on the 100-inch telescope on Mount Wilson the so-called Michelson stellar interferometer, which actually measured the diameter of the first stars from Earth. Remember, stars look like they're just points of light because they're so far away. And he found an actual appreciable diameter of Betelgeuse, the bright red star in the upper right-hand shoulder of Orion. And there's this big kludgy thing sitting up on top of the open tubular telescope, the 100-inch. And that's where I first encountered Michelson, who was a genius of mechanical design. And you mean when he said in this paper, well, we need to do the interferometer ether measurement up on top of Mount Wilson as a work in progress, nobody paid attention to the author of the paper that it's not done yet, guys. We have more to do before we can say anything definitively.
Well, there were people who took note of it and who didn't agree with the static ether interpretation. But unfortunately, they were not the top people in the sciences of the day. Now, there was a younger fellow, Dayton Miller, who was up and coming at that time. He was a PhD graduate from Princeton University Physics. He got his dissertation by making his own telescope observations of comets and calculating their orbits. This guy was a top-notch experimentalist, and he eventually became the chairman of the physics department at Case Western University.
This is in Ohio, right?
This is in Ohio, Cleveland, Ohio, and that's the place where Michelson-Morley first did their experiment. Morley was a professor of chemistry at Western Reserve University, whereas Case School of Applied Sciences was at the same location. Today they are merged together, but back then they were not. Mm-hmm. And so Miller wound up as the chairman of the physics department at Case School of Applied Science. And he became deeply interested in the ether question and partnered with Morley. There's a series of experiments by Morley Miller. And Morley Miller built a much bigger interferometer. And from 1902 to 1905, they engaged in experimental work with it. Something like 995 turns of the interferometer.
Oh, my God, compared to 36.
Compared to 36. And they determined, as calculated, 7.5 to 10 kilometers per second of ether velocity.
Now, wait. If the two experiments were done basically in the same location, the same city, why were the numbers a little different?
Well, the higher velocity of 10 kilometers per second was when they put the interferometer, which is a much bigger device, a more sensitive device than what Michelson-Morley used. They put it on some hills near to the Case School called Euclid Heights, bringing it up about 100 meters higher in elevation.
Oh.
And they put windows around the light beam path. See, the original Michelson-Morley experiment was done in a basement location at Pierce Hall in Case School of Applied Sciences, and this was a huge stone building. So they're blocking the ether by taking down into this basement location. Nevertheless, they recorded this 5 to 7.5 kilometers per second. Mm-hmm. That was Michelson-Morley. Mm-hmm. Now, Morley Miller reproduced the experiment in the same basement location, and that's where they got the lower figure of 7.5 using a much more sensitive device. But when they took it out another 100 meters higher in elevation up on a hill at Euclid Heights, and they made they put windows, glass windows, all around the structure. It was a little hut that they built, an octagonal hut, actually. They put windows all around the structure at the level of the light beam paths in the interferometer.
On the theory that stone would slow down the ether and glass, because it carries light through it transparently, would slow it down a lot less.
A lot less, exactly. And that's when they got the higher reading on Euclid Heights. Now,
wait. All right, so we go from 7.5 kilometers per second in the basement to 10 kilometers per second as a high level on the hill 300 feet higher with glass windows. So now you've got 2 points on a graph. What did they extrapolate if they could get up to mountains thousands of feet tall?
Well, there was a lot of speculation about that. But honestly, for the amount of data so far, I never read of anybody making an altitude velocity computation. I did this in my book, and I think it's one of the first, it's actually the second time somebody made an altitude velocity computation based upon a number of ether drift experiments. That
seems like such a natural. Again, there are huge holes in this story, Jim. It sounds to me like we're not dealing with just ignorance and not knowing. We're dealing with some kind of conscious design to suppress knowing.
Well, we're getting to that point. And remember, the Morley-Miller experiments, we went from Michelson-Morley in 1887 to Morley-Miller in 1902 to 1905. Now, what happened right after in 1905?
Didn't Einstein get a Nobel Prize for the photoelectric effect or something?
Yes, but that was years later. In 1905 is when he publishes.
That's when he published relative
major papers.
Okay.
And these are considered by modern physics to be the 4 papers or 5 papers by Einstein which changed the world. Okay, they say Michelson-Morley was fundamental for Einstein, but then Einstein changed the world because his theory of relativity requires you to make this metaphysical leap into the imaginary world of space-time warps and things like this, and to negate the existence of the ether. So there was a battle that was set up between over the subsequent years after Morley-Miller, between the results that they got, which was tangible experimental results made in the United States, versus the physics mandarins in Europe. We're talking about the Royal Society. We're talking about the top guys, put top in quotation marks, like Lawrence, like Fitzgerald, who, what did they do? They said the reason why the Michelson-Morley got a null result. They're interpreting it as a null result, a zero result.
7.5 kilometers per second is zero to them.
7.5, yeah. From 5 to 7.5 is the upper range of what Michelson-Morley detected. Now, Lawrence and Fitzgerald, they just ignored the Morley-Miller stuff. They've been speaking about Michelson-Morley nonstop as a null result, and they're arguing this contraction theory. They're saying that they're still believing in the ether, but they say we weren't able to detect it because when the ether is flowing through matter, it compresses it, and for the interferometer, it compresses the ether exactly the amount that's necessary for the results to be null.
So they're claiming that because of the motion of the Earth through space, there's a physical contraction of the light beam mirrors in this gadget called the interferometer in the direction of motion that exactly should cancel out the motion through an ether, which makes it undetectable, which makes it scientifically irrelevant.
Exactly. Now, the fact that they actually got a result negates the necessity for the Lawrence Fitzgerald contraction.
See, this almost sounds, Jim, like the deep state of physics with its heavy hand could not allow a positive result because of what? What was the underlying reason for dismissing real measurements of a real universe with real results?
Well, I'll tell you, my understanding of it is it's the character structure of the individual. The ether is 2 feet on the ground. Too much of having your feet on the ground. It's something you can breathe, and you can look up at the cosmos, and you can be an ordinary person, and you can fathom it and understand it. Suddenly, that was abhorrent to the physicist who lives in his head and who has to approach the universe as a complex set of equations that you can only understand mathematically. And as you know, in my book, I have very little math. There's hardly any serious math in there. It's just basic arithmetic to show how the interferometer works, some trigonometry and so forth. But it's you don't have to have tremendous maths. You know, one of the principles in good scientific method is that you use the math to evaluate for things that you already have an idea about. But if you come up with big mathematical equations and then you claim that time and space are warped, but nobody can see it, nobody can touch it, nobody can measure it actually, this is where there's a failure in science. That's why I say it's correcting a major error in modern science. The ether was measured. It is a real thing. It's a tangible cosmic force. It's a gravitational ether. But this changes so much that it's going to require a scientific revolution, certainly equal to the Galilean one, especially given how modern physics today is basically a religion. It's turned itself into a religion where heretics are punished, where having kind of a foggy metaphysical view of the world is extolled as some virtue. And as you know in my book, if you've read it, the parts in the introduction, I had big problems with the relativistic physicists. They wanted to get me thrown out of the university for some obscure little thing I wrote about the cosmic ether and a little bit critical of Einstein. They wanted to cancel my PhD and block it just because they were outraged about that. Forget.
You were a heretic.
Had nothing to do with that. I was a heretic, exactly.
So we go back to the political agenda. I'm thinking, because it can't just be a whole bunch of bright people who are suddenly very dumb, because even in his own historic paper, or their paper, Michelson Morley, they talk about the need to get up high because of a possible ether entrainment. So in their own paper, that's become a religious icon, the idea that the ether could vary and would not be as much as expected in free empty space is already endemic in the discussion. So if you've got a lot of bright people ignoring the positive results, the only conclusion I can draw is there's a political agenda here, and it was to stamp out burning ducks, i.e. an ether, because for some reason that would be anathema to a whole field of implications.
Well, it's hard for me to assess what was going on in the early 1900s. I can only go by what's printed in the historical records and by historians and so forth. But certainly today, I would say you're right, that today we've got the skeptic clubs. We've got anybody who dares criticize Einstein's theories gets pilloried. If you mention the cosmic ether, because there's prejudice against that term, you're accused of being a metaphysician yourself, even though it's the Einstein theory that's the metaphysics. Because with the ether, it's as I'm articulating it here, it's a demonstrable entity. You can measure it with light beam interferometers. And we haven't even gotten beyond Morley Miller. You know, the next steps of Dayton Miller working by himself are mind-blowing.
We will do that when we return. We're at the top of the hour. My guest this morning is Dr. James DeMeo. We're talking about the unspeakable, that space is not empty. In fact, it's filled with a medium, not even a static medium, not like, Jell-O is a metaphor, but with a medium which, as you're going to hear, swirls and moves and swoops and interacts and has extraordinary implications for everything from travel to the stars to the source of gravity itself. Here on the other side of midnight, my name is Richard C. Hoagland. We shall return. Thanks for listening to this exciting first hour. Now, the second and third hour of the show is available to Club 19.5 members only. Please support the show by subscribing to Club 19.5 and join our very interesting community. To do that, please visit the website, theothersideofmidnight.com, and click on the Join Club 19.5 link in the left-hand column. As a Club 19.5 member, you'll gain access to the rest of this show and all previous 350-plus shows that we have done. Now, recent Club 19.5 member archive recordings have the commercials removed, and the sound quality has been enhanced. You'll also receive a dedicated private podcast feed that contains these enhanced show recordings. And you'll be able to download the MP3 files directly from the archive if you prefer. As a Club 19.5 member, you'll also be the first to preview our new videos and reports. We'll be adding exclusive new features to Club 19.5 as we go forward, and boy, have we got some amazing things to tell you about in the coming weeks. So please support the show and don't miss all the exciting new things we have planned. I want to thank all our Club 19.5 members because without your guys' support, this show would not be on the air. Please help us continue growing the show by subscribing to Club 19.5 today. And when I say we really need you, we really need you. Over and out.